Welcome to Module 1 of our SIP training series. In this session, we're going to take a close look at structural insulated panels, or SIPs. By the end of this module, you'll understand what SIPs are, how they're built, and why they're considered one of the best modern solutions for creating high-performance buildings. We'll also highlight the key differences between SIP construction and conventional stick framing. This is the foundation of everything we'll cover in the following modules. So, what exactly is a SIP? Imagine a giant ice cream sandwich. Instead of cookies on the outside, you have two sheets of oriented strand board, commonly called OSB. And instead of ice cream in the middle, you have a thick, rigid layer of insulating foam. These three layers are bonded together under heat and pressure to form a structural panel. This simple but powerful design makes SIPs perform like a composite structural element, kind of like an I-beam. The OSB faces handle bending and compressive forces, while the foam core handles shear and resists deformation. Together, the assembly is stronger than the sum of its parts. The beauty of this system is that you get structure and insulation in one product. Instead of building a frame, adding studs, and then stuffing insulation between them, a SIP already comes with insulation built in. That's why SIPs are considered both an enclosure system and a structural component. Let's talk about why people are choosing SIPs over traditional methods. First, energy efficiency. SIPs deliver higher R values per inch of thickness compared to fiberglass or batt insulation. Because the foam layer runs continuously, you don't get the weak spots of thermal bridging that occur every time you have a stud in a framed wall. Second, airtightness. SIP joints are sealed during installation, meaning the whole building envelope is much tighter than a stick-built house. Airtightness is one of the single biggest factors in achieving low energy bills and consistent comfort. Third, speed. A SIP building shell can often go up in days, not weeks, because panels arrive pre-cut and ready to install. This reduces labor costs and minimizes weather delays. And finally, strength. Testing has shown that SIP walls are 2 to 3 times stronger than conventional walls of the same thickness. That translates to better performance in high wind or seismic areas. So with SIPs, you're not sacrificing durability for efficiency, you're gaining both. To really understand the difference, let's compare SIPs to traditional framing. In a typical stick-built wall, about 20 to 25% of the wall area is taken up by wood studs, plates, and headers. Every one of those studs is a thermal bridge, allowing heat to flow right through the wall. With advanced framing techniques, that percentage might drop to 14%, which is better but still a lot of wood. In SIPs, the framing fraction is under 10%. That means almost the entire wall is insulation, not lumber. This is why SIPs often outperform framed walls in energy modeling, even if the nominal R value on paper looks similar. Less wood equals less heat loss and more real-world performance. One of the most compelling reasons to use SIPs is the energy savings. Buildings constructed with SIPs typically consume 40 to 60% less energy for heating and cooling. That's a massive reduction, not just a few percentage points. But the benefits go beyond energy bills. SIPs also improve comfort. In a SIP home, the interior surfaces, like the inside face of walls, stay closer to the indoor air temperature. That means no more cold walls in the winter or hot spots in the summer. You get even, stable temperatures throughout the space. And with airtightness, drafts are virtually eliminated. That's why occupants of SIP homes often say the house feels different, quieter, calmer, and more comfortable. Airtightness deserves its own focus. When we test buildings with blower doors, standard new homes often measure between 5 and 7 air changes per hour at 50 pascals. We call that ACH 50. A SIP home can easily achieve 2 ACH 50 or even better. Passive house standards require 0.6 ACH 50, and SIPs are one of the easiest pathways to get there. Why does this matter? Because uncontrolled air leakage can account for up to 40% of heating and cooling losses in a building. Not to mention, leaks bring in moisture, pollen, and pollutants. By reducing leakage, SIPs keep conditioned air inside and outdoor contaminants outside. This is a huge win for both efficiency and indoor air quality. SIPs are incredibly versatile. They can be used for exterior walls, roofs, and floors. In residential construction, SIPs are popular for single-family homes, but they're also increasingly used in multifamily projects, schools, and light commercial buildings. In fact, because SIP panels can span long distances and resist high loads, architects are finding creative applications, like vaulted ceilings, cathedral roofs, and even entire commercial shells. Whether it's a small cabin, a modern suburban home, or a multi-unit development, SIPs scale effectively. And since panels are manufactured in a controlled factory environment, you get consistent quality no matter the size of the project. To wrap up, SIPs combine structure and insulation into one efficient package. They minimize thermal bridging, create airtight buildings, and save both energy and time. They're code-recognized, widely available, and proven in thousands of projects across North America. In the next module, we'll dive deeper into the structural side of things. We'll look at how SIPs carry loads, how they're tested, and how they meet code requirements. But for now, remember this. The SIP building envelope isn't just another construction method. It's a smarter way to build for energy efficiency, durability, and comfort.